In this video, we are going to be considering the rules of indices. The word indices is plural of index. And of course, we know that index can also be called power. For example, 8 is 2 times 2 times 2. And this can be written as 2 to the power of 3 because we've got 1, 2, and 3 here. So this 3 here can be called the index. It can be called the power. So when we have more than one power, that's what is referred to as indices. Now, there are a number of laws or rules guiding numbers or letters with powers. We are going to be solving and simplifying some problems using the rules. Here are the rules. The first one, x to the power of a times x to the power of b equals x to the power of a plus b. So we can see here that the bases here are the same and there is a product. So what we just had to do was to retain the base and add the powers. The second one, x to the power of a divided by x to the power of b equals x to the power of a minus b. So we can see here that we retained the base and just subtracted the second power from the first one. And the third one, x to the power of negative a equals 1 divided by x to the power of a. So we would see here that this power here is negative. So but here it has become positive when we've got a 1 divided by. The fourth one, x raised to the power of a over b equals the base root of x raised to the power of a. So here is a fractional index. So we would see here that the denominator of the fraction becomes the roots, like the square root, the cube root, the fourth root, and so on and so forth. And the numerator assumes the index. So here we've got the product of two items, x and y. Of course, we can have more than two items, but for simplicity, we are just going to reduce it to two items. So we've got xy enclosed within parentheses and a raised to the power of a. So the power is going to multiply each of the indices. So we've got x to the power of 1 here. So 1 times a is a. Also, the one on y here multiplies a. So we've got x to the power of a times y to the power of a. The next one is so similar to the previous one, but here we've got a quotient, a division. So the power is also going to affect each of the index. So the final one here, I love having this one as the final rule. If x to the power of a equals x to the power of b, then a is equal to b. So what this rule just teaches us is that if the bases are the same, the powers would also be the same. Here is something to think about. If x to the power of a equals y to the power of a, is x necessarily equal to y? Because here in the last law here, we have that if the bases are the same, the powers will also be the same. So do we think the converse is true? If the powers are the same, do we think the bases must also be the same? Think about that. So the next thing is going to be to apply these rules, these laws to solve, to evaluate, to simplify a number of problems. Okay, let's take a few examples. The instruction is to simplify. So the first one is y squared times y raised to the power of 5. So what we are just going to do here is to compare what we have here with these laws and see the one that perfectly matches it. So here we can see that we've got the same basis here, y and y, and a product, a multiplication between them. So the first rule is going to be most applicable. And the first rule says, just take the base and add the indices. So this is just going to be y raised to the power of 2 plus 5. And this is y raised to the power of 7. Very simple and straightforward. The second one, we've got x raised to the power of negative 3 times x raised to the power of negative 2. Similarly, we would see that the bases here are the same, and we've got the products. So we're also going to use the first rule, which requires us to add the powers. So the first power here is negative 3. Then the addition sign. The second power is negative 2. So this is going to be x This is negative 3, plus minus is minus, and this gives x raised to the power of negative 5. But we may not necessarily stop here. We can still proceed further. What we have here has a negative index. So scanning through these laws, we would see that law 3 can still help us resolve this problem. So the negative index is just going to translate to 1 divided by the base raised to the power of a. So comparing this, we would see that x remains x, but a equals 5. Thus, x raised to the power of negative 5 is just going to be 1 divided by x raised to the power of 5. So what I've just used here is rule 3. Rule 3. So here, in the first two instances, I used the first rule. Okay, question 3. How about 3z raised to the power of 5, then a 4 outside of it? Now here we would see that we've got two items here, 3 and z raised to the power of 5. Both of them enclosed within parentheses and an index of 4. So what this tells us is that this 4 is going to affect each of the items within the parentheses. What we have here looks exactly like this. So the power outside is going to multiply the respective indices on each of the items. So we're going to use rule 5. X is 3 here and y is z to the power of 5 basically. So this is just going to be 3 raised to the power of 1 times 4 because we've got a 3 raised to the power of 1 here. Then there is a product between 3 and z raised to the power of 5. So times the index on z is 5. We're going to multiply that as we have here. So this is equal to 3 to the power of 4 times z. 5 times 4 is 20. And we know that 3 to the power of 4 is 81. So this is 81z raised to the power of 20. We are going to continue in the next video. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media, drop a comment, and don't forget to click on the subscribed icon. To get notified when I upload new videos, select the all, that is the dark bell button on the subscribed icon. Thank you for watching once again. See you in the next video.